Hey, what's going on guys? In this video we are going to see how to solve this first order linear differential equation. Here you can see this is first order linear differential equation. At the same time this is separable. Separable means you can bring all the y to one side and x to other side, and you can do the integration both sides and find the solution. Now here we are going to see how to solve this one using first order linear differential equation method. Like we are going to see how to do this using integrating factor. Like we multiply by integrating factor, and after that we integrate and find the final solution. Now first of all we have to have this one in a standard form, and we know that first order linear differential equation standard form will look like this. We will have dy over dx plus p of x multiplied by y, and other side we will have q of x. So we have to have dy over dx right here. Y prime is dy over dx, and after that we have to have a function of x multiplied by y. But here you can see the function of x multiplied by y is in the other side of the equation, so we have to bring this one in this side. In order to do that, first what I'm going to do, I'm going to multiply this x cube by 1 and y. In that way we can bring it into this pattern. If I multiply this x cube by 1 and y, we are going to have x cube minus y x cube, and we want to have something with multiplied by y and function of x in this side. So this is the one that is suitable for that. So I'm going to bring this part into this side. If I bring that one, this is going to be what we are going to have dy over dx, and this minus yx cube will become plus yx cube, that is equal to x cube. Now it's better to write x cube y, because in order to find the integrating factor we have to use an equation. I will show you the equation, but before that I write this one x cube y. The equation look like this: in e power integral p of x dx. This is the equation to find out the integrating factor mu. Now what is the p of x? P of x is the value that multiplying y at this location. And here you can see this is the function of x that's multiplying y. This is our p of x. So we had to bring this p of x and apply in this equation in order to find out the integrating factor. So mu is equal to e power integral x cube dx. Now if you integrate x cube, that's going to become x power 4 divided by 4, e power x power 4 divided by 4, and that's it for this one. Here we will have a constant, but for integrating factor we can neglect the constant, because at the end we are going to bring all the constant together. And also you can see, like if we add the constant right here, we will have a plus c. So plus c mean it's multiplying by e power c. So after we find out the integrating factor, we have to multiply the integrating factor here, and also with this one, and also with this one. From that one you can see, since we are multiplying this one both sides, the constant can be cancelled both sides. So we don't even have to worry about this constant, because it's going to cancel anyway, right? So we can just write this one. And then after we find out the integrating factor, we have to multiply everything by integrating factor. So when we do that, we will have dy over dx multiplied by e power x power 4 divided by 4, plus this one also will be multiplied by e power x power 4 divided by 4, x cube y is equal to x cube, that one also multiplied by e power x power 4 divided by 4. Now the reason we are having integrating factor is to simplify, because when we multiply by this one by integrating factor, the derivative of this one, if you take the first part alone, d over dx, I move this y to inside, y e power x power 4 divided by 4, and if you find the derivative of this one, you will get a chain rule, and that will give you this result. This whole results will be given, like you can derive the whole results when you do the integration. I mean when you take the derivative of this one. So that's why when we do the integrating factor, this is the part that's going to come in the next equation, because the reason we are having integrating factor is to simplify like this. Okay, so we just have to bring the first term and write this one and equalize to other side. x cube e power x power 4 divided by 4. Now after we found out the multiply everything by the integrating factor, we had to do the integration both sides. So here we had to do the integration with respect to x, here also we had to do the integration with respect to x. Here integration and derivative cancels each other, so this is the part that's going to remain. So finally we will end up with this part, y e power x power 4 divided by 4 will remain in this side, but in the other side we had to do the integration. But here you can see, here we have power, the derivative of power is outside. We have x cube dx. If you take the derivative of x power 4, that's going to give you 4x like 4x dx. So you can do the use of 4x cube dx. So if you have derivative outside, you can do the u substitution. Here you can see, like you can do it in your mind. Like if you do that, you have to divide this one by derivative. What's going to be the derivative? If you substitute u, you will get 1 over 4. If x power 4 is u, then 1 over 4 you have to divide by 1 over 4 u. Like let's do it simply. So let's go ahead and substitute. Let's do the u substitution. I do it shorthand, but let's go ahead and do it. Okay, let's substitute x power 4 for u. So if x power 4 is u, then du is going to be derivative of this one, 4x cube dx. Here we have x cube dx alone, so du by 4 is equal to x cube dx. Now we can go ahead and replace everything in terms of, let's do it separately like this. So we can do the integrate, like we can change everything in terms of u. So integration, instead of x cube dx, I replace that one with du by 4. 1 over 4 is a constant, so I can move that one to the front. And then we will put du right here, and we know that x power 4 is equal to u. So I put e power u divided by 4. Okay, now when we do the integration of this one, what we have to have, e power 4. When we do the integration of e power something, e power doesn't change, but we have to divide by the power. So u over 4 will be divided, and we will have, when we do the integration, we will have this one, and that's it. So this will be divided, and here we will have what, u is equal to x power 4. So we will have e power x power 4 divided by 4 divided by x power 4. Power x power 4 divided by 4. Something wrong here. Let me see. X cube dx. Okay, 4x cube dx. X cube dx. du by 4. 1 over 4. We are integrating here. E power u over 4. And it will be divided by its derivative, the derivative on top. So that's going to be just 1 over 4. So this u will not be here. So this is going to be just 1 over 4. This 1 over 4 and this one cancel. We will have just e power u over 4. That's e power, if you replace u, that's going to be e power x power 4 divided by 4. So this is the integrating, the derivation of this one. So after we find out the derivation, we can write our final answer. Y x power 4 divided by 4 is equal to e power x power 4 divided by 4. But the final answer we have to write in terms of x power 4 divided, in terms of y. So we have to divide both side by, let me see, this is also e power x power 4 divided by 4. This one also e power 4. E power x power 4 divided by 4. So from this, and also we will have a constant right here. So from this one you can see, when if we want to write this one in terms of y, we have to divide everything by e power x power 4 divided by 4. So this one will be cancelled, this one will be cancelled, but this one will be divided by e power x power 4 divided by 4. And that's going to be the general solution. So the general solution for this differential equation, let's get rid of this part. So the general solution, let me write the general solution here. So the general solution for this differential equation is y is equal to 1 plus c divided by e power x power 4 divided by 4. Okay, so this is the general solution, but also if we can bring this e to the upper side. If we do that, that's going to become just negative power e power negative x power 4 divided by 4. Now when we have an initial value given, we have to find out the particular solution. So this is the general solution. Now we have to find out the particular solution. Particular solution is we have to substitute this xy value and solve for c. After we find out the c, we have to plug it back in this equation and express our final answer. Now here, if we have something like this, this is our x value, this is our y value. Now let's go and plug it right here. Y is equal to 3 is equal to 1 plus c is the one we have to solve. E power negative x is 0, so 0 power 4 divided by 4. So 0 mean if it's 0 power 4, that's going to be just 0. 0 divided by 4, that's going to be just 0. So we will have just 1 plus c times 1 is equal to 3. Therefore c is going to be 2. So the final particular solution for this differential equation is going to be y is equal to 1 plus 2 e power negative x power 4 divided by 4. And that's it. This is our particular solution for this differential equation. You can also use the separable method. You can also separate and integrate, and you will end up with the same answer. I hope this helps. Thanks for watching. See you next time. Don't forget to subscribe.